This is part 2 of our day 3 lesson on parallel lines, and this lesson relates parallel lines and triangles, and we're going to see how we need to know a little bit about parallel lines to prove our first theorem here, which is the triangle sum theorem. What does the triangle sum theorem say? It says that the measures of the angles, the measures of the interior angles of a triangle, the sum of the measures, is 180 degrees. You've known this for many, many years, but what you probably didn't know is that it had a name, and that's its name right there. All right, and how do parallel lines enter into this discussion? Well, if I'm going to prove this theorem, you remember which I told you we do have to prove theorems, then what I have to do is I have to draw this line PR parallel to this side of the triangle AC. I'm not able to do this proof without doing that. That's why I copied this proof and put it into the notes rather than having us do it ourselves, because we've never really done one in which we had to add something to the figure. So what I want you to do, it would be a good idea if you would cover up the rest of this proof, cover up these steps, and see if you can complete the rest of it yourself. You should be able to once you know that what you have to do is draw this parallel line. Okay, at a minimum, read through that proof and make sure that it makes sense to you. All right, what do we have next? We're going to talk about remote angles of triangles. I'm sorry. Talking about remote angles in a minute. Right now I'm talking about an exterior angle. An exterior angle of a polygon, or in today's case we're only talking about triangles, but an exterior angle is formed by a side and an extension of an adjacent side. So if we have a triangle here, we know that this one, and this one are interior angles, but if we extend this side, and here's the adjacent side, then here, this angle here is an exterior angle of our triangle. And of course we could draw 3 exterior angles if we wanted to. All right. Now for each exterior angle of a triangle, the 2 non-adjacent interior angles are its remote interior angles. All right, so in this little diagram I drew here, for this exterior angle, this angle, and this angle are its remote interior angles. So in other words, one of the angles will make a linear pair with that exterior angle. It's the other 2 angles that are the remote interior angles. All right, and it says down here in the diagrams below, angle 1 is an exterior angle, angles 2 and 3 are the remote interior angles. So just some diagrams there to help you realize. But maybe the best way to think about it is, anytime you have an exterior angle, one of the angles in the triangle will be a linear pair with that exterior angle. So it's the other 2 that are the remote interior angles. Okay, and finally we have one more theorem. It's the triangle exterior angle theorem, and it says the measure of each exterior angle of a triangle equals the sum of the measures of its remote interior angles. So in all these cases, what I know is that the measure of angle 1 equals the measure of angle 2 plus the measure of angle 3. Exterior measure equals the sum of the measures of the remote interior angles. Forgot my 2 there. All right, so let's work a couple of problems here, and then we'll be done with this little short lesson. Find the value of each variable. Okay, well, where can we start? Let's see. We could start with x here, or let me use my theorem that I just learned, and let me start with y, so I can practice using my new theorem. What do I know about y because of the triangle exterior angle theorem? I know that y is the sum of this angle and this angle, so 80 plus 30, so that's 110, right? And y already has the degrees on it here, you see? That's why I don't have to put the degrees on my 110. So if y is 110 degrees there, then I know that x is 180 minus that, right? Because they are a linear pair. So x is 70. All right, and then for z, well, I have the other two measures of the angles. So what I have, z is 180 minus 110 plus 40. So that's 180 minus, let me put my little minus sign in there. So that's 180 minus 150. So that tells me that z is 30. Okay. How about number 13? Well, I can easily figure out what x is, right? Because of the triangle angle sum theorem. X is 180 minus 70 plus 30. So that's 180 minus 100. So x is 80. If x is 80, then of course y is 82. Why? Because of the vertical angles theorem that tells me vertical angles are congruent. And then finally here, number 14, I got to find out what C is. What's the value of C? Well, let me see what I already know for sure. I know the measure of this angle here, right? If this one's 30 and this one's 90, that's 120. So that means this angle here has to be 60 degrees, right? That angle right there. Well, look what we have here. You can barely see these little markings here, but that's telling me that this side of this triangle is parallel to this side of this triangle. And if I consider this to be my transversal, then what do I have here? I have this 60-degree angle that I just found, and here's my angle C. What is the relationship between those two angles? They are what kind? These two angles are corresponding angles, right? Corresponding angles, which means they are congruent, which means their measures are the same. So that tells me that C also has to be 60. All right, write you a quick little summary, maybe put you an essential question up there, and we'll see you next time.